Hi, this is Mark Schuyler with Schuyler Tutoring. I'm going to be using my Scribbler whiteboard today to show you the most important math strategy for the SAT and ACT. I call it the picking numbers strategy. A rose by any other name would smell as sweet. Sometimes it goes by different names, but let's just call it the picking numbers strategy. So I've selected a number of problems from the official SAT study guide. I've pulled out maybe a half dozen problems that I think are really good examples that we could use the strategy on together. So let's start right away with number 13, with lucky 13. So you're going to notice that in this problem there are variables not just in the question, not just up here in the question, but there are also variables down here in the answer choices. So what I want you to recognize is you can only use this strategy if the variables are in the answer choices. If you look over at number 15, which happens to be the hardest question on the test, it's the last multiple choice before the grid-in section, there are only numbers in the answer choices. So you probably cannot use the strategy on that problem, but you can on number 13, which is still a problem that we would consider medium hard. So here's the thing you have to do. You have to pick a number and you want to keep it small. So in this case, they say that right here that x has to be greater than 3. So keep it simple. We're going to make x 4. Which means if we're picking 4, we're going to put it in here, and we're going to simplify this problem. Watch as I do so. I still have 1 in my numerator, but now the fractions down in the denominator become much simpler. We're basically adding together 1/6 and 1/7 now. And if you remember anything at all about fractions, you know you need a common denominator, which is clearly 42. So we still have 1 in the numerator, but now we're going to be adding a certain number of 42nds together. 1/6 translates into 7 42nds. 1/7 translates into 6 42nds. So, hey, I can really simplify this now. It is 1 over 13 over 42. Now, sometimes my students get confused when fractions are sitting inside of fractions. You know, you have a fraction in the numerator of a fraction in the denominator of a fraction. It starts to be a bit like staring into a funhouse mirror where you see reflection after reflection. It's like, what do I do here? So I just want to remind you that these are divisor bars right here. That's a divisor bar. So division is going on inside of every fraction. So one way to write it is write 1 divided by 13 over 42. That's saying the same thing. It's just saying it horizontally. And you may remember that you're not supposed to divide by a fraction. You're supposed to multiply by the reciprocal. So really it's 1 times 42 over 13. And hey, 1 times anything is that thing. So our final answer is actually 42 over 13. Now what do we do with that? Because we're almost done. We need to see which one of these 4 answers, A, B, C, or D, matches 42 over 13. So let's start with the simplest answer choice right here, answer choice C, 2x plus 5. Could that be equal to 42 over 13? Well, again, keep it simple. We got to put in the same number for x that we used up in the question. Now we're trying out the number 4 for x in the answers. 2 times 4 is 8. 8 plus 5 is 13. Oh, well, that's kind of interesting. We get the denominator. It's equal to the denominator, but not 42 over 13. So it's not answer choice C. Let's try another fairly simple one. Answer choice D seems the next most simple one. So if we put 4 in the 2 places where there's an x, 4 squared is 16. I'm going to write that up here. 5 times 4 is 20, and then plus 6, if you add the 16, 20, and 6, you get 42. Hey, that's kind of curious as well because that's the numerator. Well, it's not 42 over 13, is it? But, oh, wait a minute. One of the answers up here is 42. Remember this value here? The numerator of answer choice B is answer choice D, and it was equal to 42. And the denominator of answer choice B was answer choice C, and it was 13. So sure enough, answer choice B is the answer. We've used the picking numbers strategy to get a pretty challenging problem right, and you can see it was done easily, just working with a small number. The idea is you don't want to work with abstractions. Variables are abstractions. Much better to replace these abstractions with something concrete, like a small number, and just work with it. Square it if that's what the problem wants you to do, add it to another number, divide it by another number, and get an answer and then match. Here's the cool thing. Only one answer, B, worked out to 42 over 13. You may have noticed that answer choice A was sort of the dyslexic answer. It worked out to 13 over 42, but no, that's not what we're after. So that was your first exposure to the picking numbers strategy. What I want to do is just show you one or two more and see if a little more practice would help you out. So let's look at another problem. It's also number 13, and it's also medium hard in its difficulty level. I'll just write that right here. And when you can get a medium hard question right easily on the SAT or the ACT math test, that's a really good thing. So once again, we see that all the answer choices have at least one variable in them. You can use the picking numbers strategy if it has one or more variables. Once again, it's X. And this time, it's not telling us that X has to be a number greater than 3. It's saying nothing at all. So we're going to approach this by keeping it simple. Again, there's a famous acronym, KISS, and it means keep it simple, stupid. Some teachers are really nice, and they've changed it to keep it simple, students. So we're going to pick X. Let's pick 2. Don't use 0 or 1. Let me repeat, do not use 0 or 1 for X because they have a lot of weird properties. So we're just going to use the number 2. Oops, I see in the denominator it might not be a good idea to use the number 2 because I see that would create a negative number. So you know what I'm going to do instead? My favorite number is 5. It's small enough, it's a nice small number, and it will definitely keep us from having a negative in the denominator. So I'm going to end up putting it here and here and here. So let's see what we get when we try out. We pick the number 5. We're going to have 5 squared, which is 25. This is in the numerator, minus 10. Minus 5, and then down in the denominator, 5 minus 3 is 2. Let's simplify this. 25 minus 10 is 15. 15 minus 5 is 10. 10 divided by 2 is 5. Now, that's kind of a coincidence, but when x equals 5, the answer that you get to this equation is 5. When 5 goes in, 5 comes out. Which means that we're looking to see which answer choice down here will also equal 5. Only one of them will. So I think it's a good idea to set each answer choice equal to 5. It only takes a second. And then we look them over and we say, is there one I want to start with because maybe it's easier to work with? No, so I'll just start with A. I'm going to put 5 in for both the x's here. Now right away, 5 minus 5 is 0, okay? And then we're going to have negative 20 over 2, which is a final answer of negative 10. Is negative 10 equal to positive 5? Heck no. So it's definitely not answer choice A. You know what? I think we're going to get a negative from B as well. We put in a 5 here. 5 minus 5 is 0 again. And then we have negative 10 over 2. So, you know what? Negative 10 over 2 is negative 5. But negative 5 is not equal to 5. It is 10 units away. Positive 5 and negative 5 are 10 units away. They're not the same thing. So that's not the answer. If you are ignoring signs, you might fall for that answer. Let's check out answer choice C. We put in 5 for x, 5 for x. We've got 6. Okay, so we're starting off with 6. 5 plus 1 right here. That's 6. And then minus 8 over 2. Simplifying, that would be 6 minus 4, which is 2. Is 2 equal to 5? No, it's not. Okay, we only have one more. It better be this one. Let's check it out. We have the 5 plus 1, that's 6 again. And then we have minus 2 over, well, 5 minus 3 is 2. So 6 minus 2 over 2 is the same as saying 6 minus 1. Is that equal to 5? And the answer is yay! Yes, it is. And once again, we've done a pretty hard problem using the picking numbers strategy. One of the reasons I like this problem a lot is it's not very easy to solve using a purely algebraic approach. Let's say you try to factor x squared minus 2x minus 5. You're thinking, well, maybe it'll factor, and you start asking yourself, what two numbers multiply to negative 5 but add to negative 2? And guess what? You can't think of any easy integers that do that. In other words, the numerator, x squared minus 2x minus 5, is not easy to factor. So it's not like you're going to get a nice fast solution using algebra. You can do it if you remember how to complete the square. But I'm not interested in showing you that algebra technique right now of completing the square. I'm interested in showing you there's a nice, fast, simple approach, this wonderful strategy called the picking number strategy. And I hope you use it. I hope you're starting to feel more comfortable with it just seeing these two simple demonstrations. Thanks for watching. I will have another video with some very different types of problems that we can use the picking number strategy on, so look for that video as well. Thanks for watching.